The Retrieval Augmented Generation architecture, or RAG for short, provides additional context to large language models to avoid outdated or incorrect information being used in generating user responses. This becomes especially challenging when you're talking about confidential data or data that only some users should be able to access. Let's dive into some code and see how to implement a RAG application while understanding key concepts of access control in RAG apps. When you have a large language model or LLM that you interact with, let's say a chatbot for example, that LLM is able to provide answers based on the data that it was trained with. To avoid getting outdated information, AI-powered applications implement ways for said LLM to request extra information from an external resource, be it a database or even a website. Now, in most cases, no user has access to all data, so you also need a mechanism to prevent unwanted access to information. And that's where fine-grained authorization comes into play. FGA will provide granular access control information that your application can use to filter out documents that a user doesn't have access to. Using FGA can ensure that private information stays private. Let's say you work as a developer for a fictional company called Zico. You implement the company's RAG-based AI assistant that has access to domain-specific data to reply to employees' queries. That AI assistant can see everything within the cloud domain, including some private files only certain people have access to, such as the financial team has access to the forecast for the fiscal year. You, a developer, don't nor should you have access to that data. If you ask the assistant, show me the forecast for Zico, the assistant shouldn't answer the query with the forecast information. But if a colleague from the finance department asks the same question, they absolutely should be able to get that answer. Let's see this in the actual code, shall we? Here I have an application that uses OpenAI SDK, so we can get access to the GPT models. That will be our LLM. We also have the Okta FGA SDK that will let me use Okta FGA for the access control part. And the FIS node library will be our local vector store that will index the embeddings generated from the documents we have in the sample application. Keep in mind that this application is available on GitHub, and I put the link below so that you can clone it and play around with the code on your own. To set up this app, you can follow the steps on the README of the repo. That includes grabbing the OpenAI API key, creating your free account with Okta FGA, and also running npm install to get all the libraries needed. Assuming that you've done that, you should be able to follow along with me as we go through the next steps. Go on, pause the video, clone the repo, and set it up. I'll wait. Now, once you create your Okta FGA account, you land here at the Okta FGA dashboard with your FGA store. A store in Okta FGA is an entity to organize all the authorization check data for your application. So let's create our first model. You can use the one we have in the repo README. So let me grab it. Copy it and paste it here. And remember to click save. I always forget for some reason. Now your model is updated, things start to get interesting. First, you notice that the model preview is different from the one we had in the beginning. This new model represents all parts involved in our application. It contains information about the relationship between users and objects, and in our case, objects are going to be documents. Speaking of relationships, they outline if a user is a viewer or owner of a document. There is one other thing that we need to do to be able to run our application. That is creating a client. The client is responsible for talking to the Okta FGA, and our client will be able to update the rules for access control and read the relationship data. That will be important so that our reg can, at the end, filter out documents that the user doesn't have access to. We are going to see that in a little bit. So let's create the client. To do that, you need to navigate to Settings here, and then scroll to Authorize Clients and click Create Client. Give your client a name, OpenAI, Reg App, and check all the permissions. The first one, read and write model changes and assertions, refers to the creation and modification of the authorization model. The second, write and delete tuples, lets the client populate and manage the relations data for the authorization model. And the last one, read and query, refers to querying the decision engine, for example, checking authorization and listing objects. Okay, now let's run our first script, the FGA init. This will create our first relationship tuple in the Okta FGA. In this script, we define our client and give it the information from Okta FGA as variable set in the .m file. And here, in this line, we create the tuple using the write function. Now, you should be able to see the tuple in the dashboard under tuple management. As you can see, you can pretty much do all the configuration for access control data both through the dashboard or using the OpenFGA SDK. But before we run our reg, let's understand what this tuple represents. Basically, it says that all users are able to view the public document. And what public document, you are wondering? Well, in the simple application, we have two types of documents. The public document that contains information publicly available about Zico, and the private document that contains financial information about Zico. You probably see where I'm going with this, right? Only the financial team should be able to access the information in the private document. Now let's actually run our application. npm start. If you configured everything properly, you should see the answer saying you don't have any forecasts or predictions for Zico. And how is that possible? I'm so glad you asked, let me tell you. This application is set up to pose the question automatically once you run npm start. Here in the index.ts, we have a predefined user1 and the query itself. Once you run the app with npm start, here's what happens. The reg pipeline reads the documents that will be used for extra context. It creates the files index using files node library and encode them using the OpenAI embeddings API, using the function local vector store. In order to filter out the documents based on user permissions, an instance of FGA Retriever is created. It wraps vector store search that lists documents relevant to the user query. Then, context is added by consulting both the vector database to obtain the documents that are relevant to the user query and the FGA model to filter documents based on the user permissions. Finally, the query and the context are once again passed to OpenAI to generate the response using GPT-4o mini model. And the answer is printed out in the terminal. Seems pretty simple, no? Now let's say user 1 is the new hire for the financial team and you need to give them access to the private document. To do so, let's create a tuple to reflect that. Now, here back on the dashboard, let's go to the tuple management tab and create a tuple giving user 1 the access to the private doc. Let's fill in the details. The user need the user ID, so user 1, and then the object, we need the type doc, and we need private doc, which is the name of the document which has financial information. And we are going to let this person view doc. So viewing should be enough to query the information using our AI app. And now run the script again with npm start. We get the forecast. Isn't it magical, like one simple relationship can do so much for our application? All jokes aside, thank you so much for spending the past few minutes learning about RAG and access control. I hope you had as much fun as I did trying out the code for yourself. Now, before you go, a tiny reminder. We have a bunch of links below, including the GitHub repo with the code that I just showed you, and a blog post with even more details in case you want to go deeper. I'm looking forward to your comments and questions, and I'll see you on the next one. Bye.